Some basic science and chemistry. I think not that we want to go deep into the topic of chemistry, some people find it scary. I think it's really important to understand that all those different minerals on the periodic table, the copper and the zinc and the boron and the cobalt and the molybdenum, they all, when it comes down to it, have different sizes and shapes. Each mineral has a certain number of protons and electrons and neutrons. People may remember that from school. But they also have a functional size and shape. Each mineral has a bonding geometry. Some minerals will bond in 8-sided geometry, some minerals will bond in 10-sided geometry, some minerals bond in 6-sided geometries. Which means that they have, if you can think about a tinker toy and the different angles that are coming out of those different centered tinker toys, a 10-sided geometry means can have a lot more different sticks coming out of it and creates a much more nuanced shape out of it. So a lot of the simpler elements, the hydrogen and the helium and the those elements at the top of the periodic table are not very complex, do not form interesting shapes, but the trace elements and the minerals that we need in parts per million and parts per billion, we don't need many of them, but we do need them because they are the core of enzymes. And as I said earlier, enzymes are critical for all biological processes, for all of our endocrine systems to work, for our glandular processes, for our reproduction of our cells. All of our biological processes are enzyme dependent, and those enzymes all have, or not all, but almost all enzymes have at their core these trace elements. And each of those trace elements has its own unique size and shape, and if you don't have that size or shape present, you can't have that enzyme, and if you don't have that enzyme, then you can't have that process being accomplished. So for the want of a little bit of cobalt, a whole slew of biological processes are unable to be accomplished. This is a critical point in understanding how biological systems work. I would suggest it's a place where a lot of organic farmers have fallen down because they have not been looking into and addressing these key minerals from a systemic fashion in their agricultural practices. In closing, I'd like to say that from my perspective, we understand that our soils in many cases are deficient in mineralogical and biological attributes, sometimes organic attributes, and what that means to a lot of people is they need to buy something. My opinion is that certainly there are a number of good products on the market, some very, very good products in fact on the market, but on principle we should be able to access all of the minerals and all the biological communities that we need from our local environment. Nature did not need to buy anything to set up what was a very, very bountiful biological system when white man first came. All nature used were the locally occurring natural materials over time in a creative process. I would suggest that as far as raw materials are concerned, between rock minerals, which can be found at local quarries, we're talking about basalts and granites, all sorts of different rock materials, between rocks and the ocean, we have effectively all of the base materials we need to bring in from off-site to our agricultural projects. So certainly there are a number of good products on the market, but if one so chooses, accessing materials from the local environment is all one needs to do to address deficiencies.